Howdy. In this lesson, we're going to be applying our circulation that we found in the previous lesson in order to calculate the lift on a symmetric airfoil. So if you remember, our gamma term was equal to 2 alpha v infinity 1 plus cosine of theta divided by sine of theta. We're applying this over a symmetric airfoil. So again, our chord line and camber line are equivalent. And in order to do this, we're going to use the association between lift and circulation. So lift per unit span is simply equal to rho v infinity capital gamma. Now our circulation is going to be the integral along our chord line of gamma times dc, which is to say we're simply summing up each of these small bits of circulation in order to find the total circulation over the airfoil, which is associated with lift. Now we have gamma in terms of theta. We need to therefore transform this equation into theta. So our c term is equal to c over 2 1 minus cosine of theta, and our dc is equal to c over 2 sine of theta. So this becomes c over 2 integral from 0 to pi gamma of theta sine of theta d theta. Now we can simply plug in our gamma of theta term here. So let's say that our circulation is equal to the integral from 0 to pi, and we need this c over 2, of 2 alpha v infinity times 1 plus cosine of theta, and our sines will cancel out, and we're just left with a d theta. Now, the integral from 0 to pi of cosine of theta is equal to 0, so we can ignore that. But we're still left with a 1 here, and the integral from 0 to pi of 1 is simply pi. So this means that our circulation is equal to 2 pi alpha v infinity times, again, our c over 2. So we can plug this back into our lift equation. So our lift per unit span is going to be equal to rho v infinity. These 2's will cancel out, and so this becomes pi alpha v infinity times c. So our lift per unit span is equal to rho v infinity squared times pi alpha c. If we're interested in the lift coefficient, this becomes the lift per unit span divided by q infinity times c times our span, 1. So this is our surface area. And q is equal to 1/2 rho v squared. So we're going to end up with a 2 on this side. And this just becomes 2 pi alpha. And this is the lift coefficient for any symmetric